Hello learners, welcome to this course on practical machine learning using Google Colab. In this tutorial, I will be discussing about descriptors. So descriptors is a process by which we try to represent an image in terms of a feature vector. So feature vector is nothing but a representation of numbers. The numbers represent an abstract information about an image. Let us dive deep into this concept of descriptor. In a machine learning algorithm, we have 5 fundamental steps to be followed. So the first step is the collection of data set. Once we collect a data set, this data set should have 2 important characteristics. One is we should have more amount of data so that we can create a large experience to the machine, and also we should have a variety in our data. So after collecting the data set, we divide the data set into training data and test data. So the training data is used for teaching a machine, whereas the test data is used to evaluate a machine. So after splitting up of the data into training data and a test set, so the image can be given as it is to a machine to learn, which means I can give the raw pixel values as it is for a model to learn. On the other hand, I can also extract some information from the image using some feature extraction algorithm, and that extracted feature can be given to a machine to learn. So in this tutorial, we are going to talk about this feature extraction process. So we are going to talk about different algorithms by which we are going to convert our input image into a feature vector. So this feature vector is nothing but the numbers which represent an image. We are not going to use it as a pixel values. We are going to use the extracted information from the image and we write in terms of a numbers. And these numbers will be used for training our machine. So after training our machine, we evaluate our machine using the test data. So in this tutorial and in the subsequent tutorials, we are going to talk mainly about this feature extraction process. So for which the descriptors will be utilized. So let us ask a question: how to quantify and abstractly represent an image using only a list of numbers? How to do it? How to convert? So one thing is I can take the raw pixel values, I can represent it as it is. So by doing so, what will happen? The number of computations by our model is going to increase. If I want to reduce the computation time, then what we can do is we can extract some important information from the image and we can use it for teaching purpose. So thereby the speed of computation can be improved. So now the question is how to represent this abstract information as a number. So the process of quantifying an image is called as a feature extraction. So abstractly quantify the content of an image using only a list of numbers. So we'll be using some numbers to represent the information in an image. So that we call it as a feature vector. So here I show a diagram where we take an input image. When I give this input image to an image descriptor, it gives me some number. And this number is related to some information from the image. It can be a color information, it can be a texture information, it can be a shape information, etc. So the output of the image descriptor is going to be a number. So we call it as a feature vector. So this feature vector can be used by the model to learn. So by doing so, the speed of operation of a machine learning algorithm can be improved. So what are all the reasons to extract the features from an image? To compare the images for similarity. So we can compare 2 images. So we can extract the feature vectors from the images and we can make a comparison between the feature vectors, whether they are similar or not. To rank images in the search result. right? So if I want to build some search engine, I want to see how this query data is similar to the data available in the database, and then I can rank it, which is more appropriate in the data set, and which is the second best matched one, third best matched one, fourth best matched one. So like that we can able to rank our data in the data set according to the query image. And also we can use it for training our image classifier and to recognize the content in an image. So there are two major types of descriptors. One is image descriptor, another one is feature descriptor. So an image descriptor is nothing but an algorithm and a methodology that governs how an input image is globally quantified. As a whole image, how we are going to represent it. So the output of the image descriptor will be a feature vector. So this feature vector represents the entire image, the complete image. Such an algorithm is called as image descriptor. Once again, let me repeat it. So an image descriptor governs how an input image is globally quantified and returns a feature vector. So there are different algorithms. Some of them are color channel statistics, where we use the statistical information of color channels. If it is a RGB image, we can extract the mean value of red channel, green channel, blue channel. Same way, standard deviation value of red, green and blue, skewness value, kurtosis value. So like that we can take some statistical parameters of color information from the data. We can also create a histogram. Color histograms can be formulated. So histogram gives the distribution of color in an image. We can make use of this color histograms in our machine learning algorithms. We can use local binary pattern. Local binary pattern gives the texture information, how texture varies in our input data. So that can be obtained using a local binary pattern. So these are some of the algorithms, and there are many more algorithms which comes under your image descriptor. So as we extract the feature vectors using an image descriptor, we can immediately pass it on to a classifier to recognize the content of an image, or we can use it directly on building an image search engine. So one important aspect of this image descriptors are, it is not robust to change in rotation, translation and viewpoints. So it will not work well when there is a rotation of input data or translated data, X translation or Y translation, or if the viewpoint varies, again it will not work. So there is a second type of descriptor which is called as a feature descriptor. So feature descriptor is an algorithm and methodology that governs how an input region of an image is locally quantified. So what we do here is, we are not going to globally quantify an image. We are going to take a local region. We are going to take a small region in an image, and for that small region we get a feature vector. So like that, a single image can be break down into small regions. For each region we try to get a feature vector. So what happens if I give one image, if I divide that image into 4 sections, then I will get 4 feature vectors out of a single image. So here we are trying to quantify the image locally. For a region in an image, we get a feature vector. So like that we do it for the entire image. So in a feature descriptor, it accepts a single input image and it returns multiple feature vectors. Whereas in the image descriptor, what happens? A single image, you will get 1 feature vector. Whereas in a feature descriptor, depending upon how many sections we are going to make out of the single image. If I take 10 regions in a single image, then I will get 10 feature vectors. If I take 100 segments in an image, then I will get 100 feature vectors. So there are different algorithms which works on this feature descriptor concept, like scale invariant feature transform, shift algorithm, surf, or brisk, brief, and freak, and there are many more algorithms. So these feature descriptors are very powerful. Why? Because we are quantifying it locally, not globally. So an image is divided into many segments, and for each segment we are trying to quantify it. So thereby it is very powerful. But what happens to the computation time? Computation time is going to increase. Why? Because a single image is converted into multiple feature vectors. So we need to process the multiple feature vectors, so thereby the computation time will be high. And another important advantage of this feature descriptor is it is more robust to changes in input image, which means it is rotation invariant, translation invariant, viewpoint. It can able to perform better. If I have a change in viewpoint also, it can able to perform better. So these are some of the advantages of a feature descriptor. So in the subsequent lectures, I'll be discussing the different algorithms which comes under your image descriptor and feature descriptors. We will look at the programming aspect. We will take some applications where this image descriptor and feature descriptors will be used. All those details will be dealt in the future lectures. So with this, let me conclude this video. Thanks for watching. Please subscribe for more technical learning. In the subsequent videos, we will talk about the coding aspects of different image descriptors and feature descriptors. Thank you.